Imagine for a moment the world's biggest thermostat, hidden deep beneath the ocean's surface, suddenly decides to crank up the heat. What if I told you that this hidden force could dictate whether your summer is a scorching drought or an endless deluge, and that it's already showing signs of a dangerous surge, possibly culminating in a Super El Niño this 2026? For centuries, humanity has looked to the skies, trying to read the whims of weather. But what if the biggest clues lie not in the clouds above, but in the vast, swirling depths of our oceans? Today, we're not just talking about passing storms. We're diving deep into the powerful ocean atmosphere dance known as ENSO, the El Niño Southern Oscillation, and what its extreme form, a Super El Niño, could mean for nearly every corner of the planet. We'll explore what it is, why it happens, and what forecasters are seeing on the horizon for 2026. This isn't just about science. It's about understanding the very fabric of our climate and preparing for what might come next. Let's start with the basics. When we talk about weather, we're usually thinking about what's happening outside right now. Is it sunny, raining, windy, hot, or cold? That's the daily forecast, the short-term snapshot of our atmosphere. But climate is the long-term average, the overall pattern of weather in a specific place over many years. Think of it like this. Weather is what you wear to work today, while climate is your entire wardrobe. And influencing this global wardrobe, like an invisible hand, is something called ENSO. This isn't just a fancy scientific term. It's one of the most powerful natural climate patterns on Earth. A giant pendulum swinging between two extremes, El Niño and La Niña. So, what are these mysterious names, El Niño and La Niña? Picture the vast Pacific Ocean stretching from the Americas to Asia. Normally, strong trade winds, which blow from east to west across the tropical Pacific, push warm surface water towards Indonesia and Australia. This leaves cooler water to well up off the coast of South America, bringing nutrient-rich waters that feed marine life and influence local weather. This is the normal state, or sometimes even a La Niña state, which is characterized by cooler than average ocean temperatures in the central and eastern tropical Pacific. During a La Niña, those trade winds are even stronger, piling up even more warm water in the west, and bringing more significant upwelling of cold water in the east. For places like the southwestern U.S., La Niña often means drier conditions, while the Pacific Northwest can see more rain. Australia often experiences increased rainfall and even flooding. Then there's El Niño, which is La Niña's mischievous twin. The name El Niño means the boy in Spanish, a reference to the Christ child, because Peruvian fishermen historically noticed these warming events around Christmas time. During an El Niño, those usual trade winds weaken, or sometimes even reverse direction. This allows the warm water that was piled up in the western Pacific to slosh back eastward across the tropical Pacific, like water in a giant bathtub. This leads to a significant warming of the surface waters in the central and eastern tropical Pacific, sometimes by several degrees Celsius above average. This warming isn't just a surface phenomenon. It extends deep into the ocean, releasing immense amounts of heat into the atmosphere. The ripple effects are profound. This shift in ocean temperature disrupts atmospheric circulation patterns globally, like a massive domino effect. Typically, El Niño events occur every 2 to 7 years, and they can last anywhere from 9 months to a year or more, usually peaking during the Northern Hemisphere winter. They bring a kaleidoscope of climate changes, altered rainfall patterns, shifts in hurricane activity, and changes in temperature extremes. For instance, during El Niño, regions that are usually wet might become dry, and vice versa. Think about it. A seemingly distant ocean phenomenon can decide if your crops thrive or fail, if your winter is mild or frigid, or if your coastline faces extreme storms. It's a testament to how interconnected our planet's systems truly are. Now, let's talk about something even more intense: the whispers of the Super El Niño this year. The term Super El Niño isn't an official scientific classification with a specific temperature threshold, but it's widely used to describe an exceptionally powerful El Niño event. These are the kinds of events where the warming in the Pacific isn't just significant, it's off the charts. We're talking about ocean temperatures that are unusually warm, even for an El Niño, leading to even more extreme disruptions in global weather patterns. The 1982-83, 1997-98, and 2015-16 events are often cited as Super El Niños because of their extreme intensity and widespread devastating impacts. When scientists talk about a Super El Niño, they're referring to an event that pushes the boundaries of what a typical El Niño can do, magnifying its effects and impacting an even broader range of regions with unprecedented severity. While predictions this far out always carry a degree of uncertainty, the ocean and atmosphere are complex beasts after all. The signals scientists are observing today suggest conditions are potentially setting the stage for such an event by 2026. So, what causes these colossal super versions of El Niño? And why are scientists concerned about this year's weather? The primary driver is an abnormal buildup of warm water in the western Pacific Ocean. Imagine a massive reservoir of superheated water accumulating near Indonesia and Australia. Normally, the trade winds act like a dam, holding this warm water there. But when these trade winds weaken significantly or even reverse, that dam breaks. This allows the warm water to surge eastward across the Pacific, a phenomenon known as an equatorial Kelvin wave. This isn't just surface warming. The entire upper layer of the ocean, the thermocline, which is the boundary between warm surface water and colder deep water, gets pushed deeper. When the thermocline sinks in the eastern Pacific, it makes it harder for the colder, nutrient-rich water to rise to the surface, further enhancing the warming. What triggers this weakening of the trade winds? It's often a combination of factors, including naturally occurring atmospheric waves and subtle shifts in pressure systems. While El Niño and La Niña are natural phenomena that have occurred for millennia, a warmer baseline ocean temperature due to climate change could potentially intensify the impact of these natural cycles. It's like adding fuel to an already powerful engine. The current observations point to a considerable reservoir of subsurface warm water building up, which, combined with other atmospheric signals, is prompting concern among climate models. Now, let's get down to what a Super El Niño could actually mean for different parts of the world. The impacts are truly global, often bringing feast to some and famine to others. In South America, especially along the Pacific coast from Ecuador down to Chile, a Super El Niño typically brings a dramatic increase in rainfall. This can lead to severe flooding, mudslides, and erosion, devastating infrastructure, agriculture, and local communities. For instance, During the 1997-98 Super El Niño, Peru experienced some of its worst floods in history, with millions affected and extensive damage. However, paradoxically, other parts of South America, particularly in the Amazon basin and northeastern Brazil, can experience severe drought due to altered atmospheric circulation. This can lead to widespread wildfires and food insecurity. Moving north to North America, the effects are also varied. For the southern tier of the United States, El Niño often means a wetter, cooler winter, which can be a blessing for drought-stricken areas. But a Super El Niño might mean excessive rainfall, leading to increased flood risk in California and the Gulf Coast. For the northern states and Canada, El Niño typically translates to warmer and drier than average winters, which can impact ski seasons, energy consumption, and even public health by reducing cold-related illnesses. On the flip side, El Niño tends to suppress hurricane activity in the Atlantic basin due to increased wind shear, which can tear storms apart. However, it can also increase the likelihood of tropical cyclones in the Pacific, posing a threat to Hawaii and Mexico. Across the Pacific, Asia also feels the profound effects. Southeast Asia and India often experience altered monsoon seasons. While some regions might see increased rainfall, others typically face prolonged droughts, leading to widespread agricultural losses and water shortages. Indonesia and parts of Australia often suffer from severe droughts and an elevated risk of devastating wildfires, as happened during the intense El Niño events of the past. The 1997-98 El Niño, for example, fueled widespread haze and fires across Indonesia, impacting air quality and public health across the region. China might experience milder winters, but also increased flooding in some areas and droughts elsewhere. And speaking of Australia, it's often one of the hardest hit continents during an El Niño, especially a super one. The normal rainfall patterns shift, leading to widespread drought conditions across much of the country. This significantly increases the risk of bushfires, puts immense pressure on water resources, and severely impacts agriculture, which is a backbone of the Australian economy. The Great Barrier Reef also suffers, as warmer ocean temperatures can cause widespread coral bleaching, threatening one of the world's most biodiverse ecosystems. For the general public, what does all this mean? It means understanding that the world's weather isn't just local. The ocean currents and atmospheric patterns are intricately connected, and a shift in one part of the globe can have a ripple effect on your backyard. For students, this is a live lesson in earth science, meteorology, and climate change. It highlights the importance of studying these complex systems to better predict and prepare for future events. It's a reminder that our planet is a dynamic, living system, and we are all part of its grand, unfolding story. While the exact intensity and reach of a potential 2026 Super El Niño remain uncertain, the scientific community is keeping a watchful eye on the Pacific. We might not be able to stop these massive natural cycles, but understanding them empowers us to better prepare, adapt, and build resilience in the face of their power. Staying informed through reliable sources, like your local weather agencies and international climate organizations, is key. If you found this deep dive into El Niño and the potential Super El Niño fascinating, then check our channel for more interesting videos. And, as always, keep asking why on YouTube.